let's prove a function is strictly increasing on an open interval where its derivative is positive. Okay. So now let fx be a function on an open interval whose derivative is positive. Okay. Now let x1 is less than x2 in any of the open interval I, or we can say now that x1 and x2 on the closed interval, x1 and x2 on the closed interval is a subset of I. fx is continuous on closed interval x1 comma x2 and derivable on open interval x1 comma x2. Now when I have written this line, do you remember something? Yes, it is what? Lagrange's mean value theorem. Okay, so we can write it by Lagrange's mean value theorem there exists a small value c where c belongs to open interval x1 comma x2 such that, now what was the theorem for that? F x2 minus f x1 upon x2 minus x1 is equal to f derivative c. There exists a small value c in between x1 and x2 such that we have to apply for this condition. This is the Lagrange's mean value theorem, and with the mean value theorem now we are going to show that a function is strictly increasing or strictly decreasing. Now for this part, now fx2 minus fx1 is greater than 0. Now why it is greater than 0? Because whose derivative is positive. Okay. So we can write it here as f derivative c is greater than 0 on the open intervals I. Okay. So also we can write it fx2 minus fx1 is greater than 0 now for these parts. Okay. Now what we are having here? We are having x1 is less than x2, or we can write it x2 minus x1 is greater than 0. Okay. Next thing, x1 is less than x2, then from this part we can write it x2 minus x1 is greater than 0. It means this is also greater than 0, this is also greater than 0. Okay. Now for this part what we are having? fx1 is less than fx2. Okay, inequality, sorry, not identity, inequality. I have changed the inequality from greater than to less than, because it could be have been minus fx1 and this goes to that side, becomes minus fx2, and then inequality will be changed when the signs are deleted. Okay, so fx1 is less than fx2. Now we can say that x1 is less than x2 implies fx1 is less than fx2. Therefore fx is strictly increasing function on in I, okay, on I or in I. Okay, so this we have proved.